Hey guys, today we're going to take a little bit of time to discuss standard costs. So, we learned in last chapter 21, where we discussed budgeting, the importance of planning out how much sales we're going to have, how much materials we're going to need, etc., etc. So we try to do our best to estimate what we expect is going to happen, and then it makes sense that we should also have a way to see if we're staying on the budget or if we're off budget, right? So that's what this chapter is going to focus on, these standards. Standards are performance goals. Typically, manufacturing companies are going to use standard costs for each of the three following product costs: direct materials, direct labor, and factory overhead. Let's talk about different types of standards. One type of standard is called an ideal standard or a theoretical standard, and that can be achieved only under perfect operating conditions, such as having absolutely no idle time, machine breakdowns, or no material spoilage. But those are really tight and unrealistic, right? So it might have a negative impact on performance because people feel like, hey, it's so difficult that I'm never going to be able to meet this. I might as well not even try. Currently attainable standards are sometimes called normal standards, and these can be attained with reasonable effort. So these allow for a certain amount of spoilage, waste, machine breakdowns, and things like that. So when reasonable standards are used, employees focus more on cost and are more likely to put forth their best efforts. There are a couple of criticisms of standard cost, as you might imagine. And, nothing's perfect, but here are some of the criticisms. Standards limit operating improvements by discouraging input beyond the standard. So people feel like, hey, as long as I'm meeting the standard, I'm doing well enough, when they should really be focusing on continuously improving the process. Standards are too difficult to maintain in a dynamic, ever-changing manufacturing environment. So if the cost of inputs and everything's always changing, it's really hard to keep the standards up to date. Standards, of course, can cause employees to lose sight of the larger objectives of the organization because they're only focused on, looking at the one little area, right? They only focus on one of those improvements, only on efficiency. And lastly, standards can cause employees unduly focusing on their operations to possible harm of other operations that rely on them. So instead of worrying about what's best for the company overall, they might be just worried about what's best going to help them attain the standard that they are evaluated upon. So let's take a look here. We're going to skip the McLean ones, and we're going to spend time talking about Norris Company. So what we're going to do here, it says we're going to do several different problems with the same company, Norris Company here. It says Norris Company produces a product that requires 6 standard pounds per unit. The standard price is $1.25 per pound. If 500 units required 2,900 pounds, which were purchased at $1.30 per pound, what is the direct materials, price variance, quantity variance, and cost variance? So let's take just a second and complete this in Microsoft Excel. Hopefully you guys are familiar with Microsoft Excel. It's a really great thing. Give me a second. I'm going to type something up here. Okay, so for this first one, let me kind of show you a little chart I've set up here, and this will hopefully help you out here. So the first thing we need to figure out is the price variance. And the price variance is going to be the difference between the actual quantity times the actual rate and the actual quantity times the standard rate. Okay, so what we're able to tell there is like I said, the price variance. And the difference between these two over here is going to be the quantity variance. So we take the standard quantity times the standard rate, and we're going to look at the difference of that and the actual quantity times the standard rate. So if we multiply these two together, we get $3,770. And if we multiply the actual times the standard rate, we're looking at $3,625. So we can see here the difference between these two is $145 of a variance. We can see here if we were able to use the standard rate, it would have cost us $3,625, but because we had to pay an extra 5 cents per pound, it cost us a $145 difference. Because it cost us more, we would call this an unfavorable variance. Okay? It would be favorable if we did it for less than what the standards were. Okay, so let's take a look here at the quantity variance, and we can see here if we use the standard rate of $1.25 for both of these, and we used a different amount of quantity, the actual quantity, and we have the standard over here, we can see that the difference between these two is $125. That's our variance. Now we have to determine if it's favorable or non-favorable. We can see here that based on the actual quantity, it cost us less than what the budget was. So we came in under budget. That's good. That's a good thing. That's favorable. So the easy way to remember this is we have the actual times actual here. We have the standard times the standard here. And in the middle, we have kind of a combination of the two. Okay, so take just a couple minutes and write that down. Do whatever it takes for you to memorize it. And hopefully that will help you keep it straight. Now, the last thing that it asked us to calculate for this was C, and that was the cost variance. That's the total cost variance. And we can see here that we have $145 of an unfavorable variance, and $125 of that is offset by this favorable variance. So this is really the difference between this one and this one. So the difference between these two here. And if we say 145 minus 125, we're looking at a $20 amount is our variance. And we can see here that that the actual amount was actually more. $3,770 is $20 more than what the budgeted amount was. Therefore, it's unfavorable. Okay, so let's take a look at this one here. Norris Company, sorry, I know that's annoying when it gets in front of it there. Norris Company produces a product that requires 3.5 standard hours per unit at a standard hourly rate of $12 per hour. If 500 units required 1,500 hours at an hourly rate of $11.50, what is the direct labor rate variance, time variance, and cost variance? Okay, so we can use the same setup to figure out what this one is. Once again, we have actual, standard, and actual and standard. So before we get started here, we're going to need to take a look and say, okay, how much are we talking about for this over here? That this standard quantity is going to be something that we have to figure out. It tells us that we're making 500 units, and it requires 3.5 standard hours per unit. Okay? So that's where we got this right here. So we look at the difference between these two here, and we have a $750 variance. And this one is going to be favorable. That means that we were less than the budgeted amount here, right? So actual times actual is smaller than actual times standard. So when we're dealing with stuff like this, cost, less cost is better. When we're dealing with revenue, more revenue is better. Okay, so let's take a look at the difference between these two here, and we're looking at a $3,000 variance between this and this. And we can see, once again, this is going to be favorable because the actual times standard here is less than standard times standard. So that's a $3,000 variance there. And so both of those two collectively, the 750 plus the 3,000, gives us a 3,750 overall variance, doesn't it? That's the overall cost variance. So we have the rate variance here. Okay? We have the time variance here. And the total of this plus this, because they were both favorable, is 3,750. That's our variance, and that, of course, is favorable. Okay, so let's take a look at this one right here. Norris Company produced 500 units of product that require 3.5 standard hours per unit. The standard variable overhead cost per unit is $70 per hour. The actual variable factory overhead was $1,200. Determine the variable factory overhead controllable variance. So we're going to see as we work this out, we're going to do it differently than we did with the previous two. And when we calculated the direct materials variance and the direct labor variance. And that's because fixed overhead costs are analyzed differently from direct labor and direct material cost. It's because our factory overhead costs have both fixed and variable cost elements. So let's see how we would work this. Okay, so to calculate this, the first thing we need to come up with is this right here. This is a standard amount of our overhead controllable, or AKA variable variance. This is the variable components, right? So based on the, if we're going to make 500 units, and then we anticipate, based on the standards, it'll take 3.5 hours. So the total of this times this gives us 1,750 hours. The standard amount of cost there is 70 cents. So we're looking at $1,225 is the standard for this. We're told in the problem that the actual amount was $1,200. So $1,225 is the standard, and 1,200 right here was the actual amount, so there's a $25 difference. And this, of course, is less, so this is a favorable variance. Let's take a look at this last one. Norris Company produced 500 units of a product that required 3.5 standard hours per unit. The standard fixed overhead cost per unit is 30 cents per hour at 1,800 hours. This is, of course, at 100% of normal capacity. Determine the fixed factory overhead volume variance. So let's see how we'd work this. So the easiest way to do this is to look at the difference between let's focus right here. So the easiest way to do this is to look at the difference between the standard hours for the actual units produced and the standard hours for 100% of normal capacity. So the difference between those two is 50 is the difference, total of 50 hours, and we're using this 30 cents per unit figure that we're given to use. So if we multiply the difference in the hours times the 0.30 there, the 30 cents, we come up with $15. And so basically what that is saying is that, or this $50 difference is saying, is that for that cost, we should have been able to milk 1,800 standard hours out of it, but we were only able to milk 1,750. Remember, the fixed cost stays the same regardless of the actual number of units produced. But if we're at 100% capacity, we can take care of 1,800, and we were not able to meet up to capacity, so therefore we're going to see that this is going to be unfavorable.